organization. So there are different types of file organizations are there, like sequential, heap, hash, ISAM, that means index sequential access method, B plus, cluster, etc. Right? So we were discussing about our sequential files already, right? So in the sequential file, one after another, it actually stores our files. And two types of methods we have, file and sorted. So file methods and sorted methods both are same, but only the difference is in the sorted method, after inserting, we have to sort it again, right? So now next one was our heap file. Here as a block wise we used to I got one message. Nihal Kos is asking, ma'am, network both be buffering hoye ase. It is in Google Meet or Discord? Some students are coming, I think. Okay, so it is coming like this. 1 second. Then heap file, in the heap file actually we use the data blocks, and here actually it is not in any order or in any sorting actually. There is no sorting and ordering in the heap file. Simply we used to store our files in block, like data blocks. So memories are in the blocks, so block wise it is there we used to store our data records, right? So yesterday till here we have finished, not yesterday, in the last class we have finished till the heap file organization, right? So now we are coming to hash file. So in hash file, what happens in hash file organization? So we are So in the hash file organization, we are having like some hash functions to find out the like address of the location where your data should be. That in like address we have to find out by using the hash function. So in the hash function, we should have the data bucket. That data bucket is where your record is going on. That means and the hash function will find out your location, that data bucket's location, that means address. And another one is hash index, that is actually find out your, some sounds are coming actually, from where it is coming. Okay, if you were able to hear, then I just continue it. So hash file organization, in this hash file organization we have three terms actually, that are like data buckets, hash functions, and like hash index. So the data buckets, that is our location, that memory location, right? And a hash function, by using some function we can find out the address of that location, data buckets location, you can say. So hash function is mapping the function that maps all the sets of source key actual record address. So where your data bucket is there, and that actual in that, in which block, that means in which bucket your data should be, that function, that address is calculated or find out by using this hash function, right? So you can use like simple mathematical function or any complex mathematical function to find out the hash function. साउंड कहाँ से आ रहा है यार? Screen share. वो दिख रहा है मुझे. Okay. So these are our hash function actually. Has like in the hash file organization, we are having the three terms. You have to remember that: data bucket, hash functions, and hash index. So these three terms you have to remember. So there are two types of hash index are there. Like a hash filing is there, like static hashing and dynamic hashing. And the static hashing actually when you are calculating the address by hash function, that time you will get the fixed address. Like for one function, for one address you will get, for one function you will get the fixed address, same address you will get. But in dynamic it may change time to time, that address may be changed time to time or based on your access or time some program, right? So like time to time it can be changed, but here in static hashing the address whichever we are calculating, that will be same, fixed, that means. So static hashing, that is, we will go through it now. Say when you are searching the like in static hashing, when a search key value is provided, the hash function always compute the same address, that's all. So always when you are calculating by using the hash function, you will get the same address. Like for example, here we are having so student id 76. Say by using the mode of 5 hash function, right, it will always result in the same bucket address 4. So like that, if it is showing the bucket address 4, it any time, every time it will show the bucket address 4 only, right? But in the dynamic it is not like that. So some operations in static hashing, you can see it. Okay. So insertion, in insertion what we will do, say when we one new record we are going to insert in our table, the time what we'll do, the hash index h generates the bucket address, right? And like the bucket address will be like h k. So hash key is k, this one k, and the s is your hash function. So unlike that, they will just generate that, and you have to insert in that particular address. So in the searching also same thing, when your new record you are going to be searched, one record you are going to be searched, then what you'll do, the same function is used to retrieve your bucket address for the record, right? Like that for your deletion also, first you have to search it without bucket address, then you can delete it. And the updating, what you'll do, first you have to search by using the search function, then delete, and after that you have to insert the new data there. Okay. So in hash file organization, in static hashing, some problem happens like a bucket overflow. Which one is we call bucket overflow, means when you were like going to insert something, when you are searching that bucket, particular bucket, but that bucket is at that time, if it is full, then it is called bucket overflow, right? So that time it is very critical to handle actually. If say they are in the static hashing, it is showing, say it is the address whichever you are getting by using the hash function, that is like static, right, fixed. So sometimes say that in that address where your hash function, which one is your hash function has actually find out and given you, that one is say full now. But now you have to insert, but already that bucket is full. What you will do? So either you have to like overwrite, or you have to delete that and read there, sorry, write there, or you have to, otherwise you have to insert more like new something else. So that type of problem comes actually. So bucket overflow means when you are searching that particular bucket address, that time that bucket is if that bucket is already having some address, or if it is already full, then this bucket overflow occurs. So this problem we can overcome by two methods. That are like open hashing and closed hashing. So let's see what is open hashing. So in open hashing, what happens? Your hash function has generated one address like 105. If the 105 is already filled with some data or full, then what will do? It will search the next available like free bucket and insert there. Right. That is open hashing. So open hashing, in the open hashing, if the bucket is full, then what you can it can do, it can go to the next free bucket where the data are not full. It can go there and insert your data. But another one thing is closed hashing. So in closed hashing, what happens? So it will not go to another one bucket, right? It will create one like a link by the same name, same bucket address like this. See here, your hash function has generated 105 for the record D3. So this 105 is already full. Then what it will do? It will create another one bucket with the same address, and that is linked with this address, and keep it there. One second. Okay, that is your closed hashing. Okay. So we are next coming to the dynamic hashing. That is the dynamic already I have said you that in dynamic hashing that we can the bucket address, we can shrink our bucket, like we can increase also, we can grow so and shrink, increase and decrease we can do based on our records. So say if our records are like increasing, then we can increase the like our the buckets also. We can make it bigger, or we can, if we don't want that much like buckets, then we can reduce also, right? So extend, it is also called extended hashing. So now one example here, say in the dynamic hashing, say for example D1, D2, D3, we are having three record. Okay, so here if you are generating three address like 1001, this three address, let's see the example here. Here for this, say if we are having only like 0 and 1 bit like bucket, then only we are having 0 and 1. Okay, but we are having here three records. So one we have given here, another one we have given here, another for D3 we don't have the bucket. So what we'll do? So here what we can do, since it is dynamic hashing, what we can do here, we can make it 2-bit address like 0001 like this. So here we can insert our D3. For D3 also we can like assign this one, right? This address. Then we are coming to the regarding hashing will come later again with details like hashing and indexing. Indexing, that two topics I'll discuss again in the later class. So now B plus file organization. In this file organization, what happened? This is like B plus 3 like tree structure this file organization is. So B plus tree file organization is advanced method of index sequential. Would I have left something? Index sequential method. It is in the next. Okay. So here, um, see this B plus tree we know like B plus tree, B tree is that is a search tree where all the records are in sorted order. Like so, here we are using this B plus tree, that file structure. 1 second. That's tree like structure. So say you are using that binary search tree. You know B tree means binary, that binary search tree only. So B plus tree is also similar to binary search tree, but in binary search tree we are having only like two two children. But in B tree we have more than that, right? There is no limit actually. So the pointer in the left and right child we are having the pointers, and the middle we have that data, right? B tree is like that only. So here we use that concept, like tree structure concept we use here in this file organization. So here you can see like left side link is showing the smaller than this data 25, and the right side is showing the greater data which are greater than 25. So 25 is our data. Now this is showing the link left side, it is showing the left child, and this is the link for the right child. So here we put the pointer only. So in the left child we put the pointer for lesser like data, and for greater we will put the in the right side link. This is pointer actually. This is a link to the next data. So here to the same way you can see it for the files goes like that. So that's why it is sometimes very easy to find out for like searching, updating, right? Exactly, we can go directly to that. So these are some advantage and disadvantage of B plus file organization. So in B plus file organization is easy, like searching is easy. Why? Because here actually already in the sorted form we used to store, right? So that is very easy. Traversing through the tree structure is easier and faster. That is correct, because B plus trees are always in a sorted order, right? So the size of B plus tree has no restriction. So the number of records can be increased or decreased, and the B plus tree structure can also grow and shrink. Yes, because B plus tree that it is not having any limit, right? It can go that we can just link it, say this pointer. So we have to whatever your data is coming, you can just link it and it can go on. Right? You can increase whatever, how many you want, you can increase it. There is no limitation. Restriction is not there, right? So it is balanced tree structure. So any insert, update, delete does not affect the performed of tree. Yeah, B plus tree is balanced tree, right? That's why the binary search tree is balanced sorted tree. This is also same like that. So since it is balanced tree structure, so there is no problem when we are going to insert it or update it and delete it, right? And it is easy to access also, and easy to and it's easier, and it is also faster. So what is the problem of B plus file organization? And this is inefficient for the static method. Okay, this type of file organization is not that much like efficient for our static method. Static if you are having static like file, for that purpose it is not that much like efficient. But for dynamic, it is okay. We can use it. So So the another one is indexing. Oh, sorry, index sequential access method. That is the ISM. So in the index sequential access method, it is the advanced form of sequential file organization. So we know sequential file organization. What is that? In the sequential file organization, we used to store this one by one, right? One after another. So that simple and easiest way of storing. So, so here in this method, what happens? Actually, records are stored in the file using the primary key. The index is there actually. It is sequential access is there. That means sequential advanced form of it is sequential file organization. So here, only extra thing what we do is the like indexing. Indexed we have to find keep and use that. So here primary key we are using as an index, and we are mapped that one with our record, right? So the index contains the address of the record in the file. So in that index we are keeping our address of the record in which file, which records. But in sequential we are not having any index, right? Sequential file organization, but index sequential file organization, in this we are having the index, so that we can keep our addresses, right? So if any record has to be retrieved based on its index value, then the address of the data block is fetched and the record is retrieved from the memory. So based on our this indexed value, we can find out the address of that particular block and fetch it. And whenever we want, we can retrieve the data from our memory, right? So here, say you are having the data record, and these are your index. So for record one, this one, and your memory data block is here. So you can directly find out this one is our like the index is this one. So here your data is there like this. So BS8K. So where this is there, you have to just find out and take your record from there, right? So some advantage. So here each record has the address of its data block. So searching this in the huge data, it is very easy and quick. And this method supports the range retrieval and partial retrieval of the records. That means it supports the retrieval of your records. It may be fully or it may be partial records you can retrieve. And since the index is based on the primary key value, so we can retrieve the data from the given range of the word value, right? That is also one advantage. Or partial actually value we can find out like some say some name we are going to find out which like starting letter starts with J, like that. This is one example just we are giving, but partial like retrieval is here possible. That's why it's given. Another one is the disadvantage of ISM. So it's take actually extra space. Why? Because we are using that index, right? So we have to keep the index somewhere. So for that we need some space, extra space. And like that, when your new records are like inserted, then these files have to be reconstructed to maintain the sequence, right? Every time when a new one is inserted, again you have to maintain for them also again newly, like then the records is deleted. Yeah, if you have deleted one record, then that space for the index, whatever you have created, that space you have to release. Otherwise, it will be waste only, right? So otherwise, the performance of the data will be slowed down. Yes, if you are not releasing the data like space, memory space, then what will happen? It will just slow down our like database. Yes, because see, you are excited at whatever storage memory you are using for that. If you are not going to release that, it will slow down your database, right? So another one is cluster file organization. So cluster means right grouping, right? So 2-3 records if you are storing in the same file, that is your cluster, like one cluster you are having. So this file will have 2 or more tables in the same data block and key attributes which are used to map this block these tables together and stored only once. And then, like you're grouping on it, right? Say 2-3 files you have kept in one cluster, and that as a whole you are going to store that. So this method reduces the cost of searching for various records in different files. So because in one group it is there, so if you can say find out where in which cluster your like data is, just you go to that, right? And no need to search all the other things. So that way it is one advantage for searching. And the cluster file organization is used when there is a frequent need for joining the tables with the same condition. So this join will be only give only a few records from the tables, the 2-3 tables if you are going to like join. From there you can some new other records, right? You can find out, right? So here another one thing here it is given is you can directly insert, update, and delete any records. So data is stored based on the key with which searching is done. Okay. So are you able to share or any disturbance is there? Okay. You can type your message like whatever you want to say, because from my side you are not audible. So if you have any queries and any question, you can type in the chat. So that is our cluster file organization. So here say we are having two like the tables employee and here your cluster key is like employee ID. Okay. From here see you can find out like from the both table you can find out the details like for maths your employee ID 7. Employee ID 7 also you can see 7 it is having Saturday Sunday off. Okay, so from here you can like see whether that employee from the employee ID itself you can find out the address and name, employee name. So it's clustered in one table, right? One group. So and another one, so okay, cluster file organization we can divide in two like types. One is indexed clusters and has structure clusters. So in index cluster, what happens is the index cluster records are grouped based on the cluster key or stored together. But in hash cluster, we have to like create that hash cluster, and we can record like store our that records there. So only the difference is that only. So work is same, but here indexed already indexed that cluster. In the index cluster you have a cluster key, and you have to like store your all the things there. But in the hash cluster what happens, instead of storing that records based on your cluster key, so we can generate the value of your hash key and for the cluster key, and we can store our record there, right? So some advantages and disadvantages are also there. Okay. Okay. So some advantages are there for cluster file organization. What are that? Say here, this cluster file is used when there is a frequent request for joining the table with same joining condition. Okay. So we can like if somewhere like 2-3 tables you can join and ask like with that condition joining condition, that frequent request if you are getting, then you can use this one in that type of thing. Then it provides the efficient result when there is a 1:m mapping between the tables. Okay, you know that mapping, right? 1:m, 1:m. That means 1:many. That mapping, if it is there, you can. It provides the good result for this type of mapping if you are having in your tables, right? So what are the disadvantages are there? So it is having low performance because it is having the large database. Because of the large database, the performance is low. So if there is any change in the joining condition, then these methods cannot use. So if we change the condition of the joining, then the traversing of the file takes a lot of time. Yes, so that is true, right? Joining condition, right? If you are going to change again and again, it will be very difficult to again construct your that joining, right? Find out. So in that case, it is not actually, we cannot use this type of organization, file organization. It don't work actually properly. So this method is not suitable for table like 1:1. So if 1:1 like condition, that mapping 1:1 mapping is there, that type of, in that type of tables you cannot use this, right? So next we are coming to the indexing and hashing, two different topics. These two topics are actually, I think, last topic. So after indexing and hashing, we'll go through the storage devices, just like basic of the storage devices. And then after that it will be over, your whole syllabus is over. So I'll upload this whole study materials in your Google Classroom. So for today's class, I will not start indexing and hashing. So another one day I will take class where I will finish your indexing and hashing. Okay. So if you are able to hear, you can just type in the chat box. And wait, I'll just take your attendance. Till that, don't go. Don't, I'll leave this screen. Okay, I have taken it. 1 second. Let me go now. Hey, body daddy. Where's my camera?